playing the music. You can hear the music in the sound effect.
Should I be playing it?
Yeah, I think you should.
Okay. It's very faint. Oh.
It's
I get it. So we'll wear these the whole time? Oh, wow,
first speaking.
I can totally hear stuff.
There it goes.
I should send the URL to myself.
There you go. Absolutely.
Where's
We are twitch.tv/C#Fritz. How's it going there, chat room? You can hear us. We're getting ready.
look at that.
Let's get some learning done. Absolutely, Sean. Hey there, Coding Gorilla. Good to see you. Tajari89. Hello, hello. Potato King is here. Welcome, Potato King. Love the names. Now we've got a Potato King with us. Hey, who knew?
Long
All right.
live the king.
Long live the king. Absolutely. So, there we go. See more folks trickle in. Trickle in, friends. Trickle in. Here we go.
Be the potato king, I think he did. King of Ireland.
King of Ireland. Maybe. You definitely can make some vodka. Right? My goodness. Yeah, the music isn't quite the same.
Yeah,
for-
it's kind of a little static.
It is. I tried. This music's normally a little bit low. It's the soundboard that we're wired into. All right. We'll give it 30 seconds and we'll get started here.
As long as we sing.
You're only hearing it from the left side? No, we've got it coming through both sides.
The others are saying the same thing now. I hear it from both.
Yeah. Audio only in the left. Interesting.
Including our voices.
Including our voices. Interesting.
There we here.
Yeah, right.
Yeah, including the voices. Experiencing technical difficulty.
Yeah,
Please stand by. Stream starts in 0, 0.
Right? Cameron? Right? You know what, let's run with it and we'll see if we can fix it along the way. There we go. Welcome back. How's it going there, chat room? My name is Jeff Fritz, and I have a guest today. It is August 13th, 2019. We're going to write a little bit of code today. It's Phil Haack. Phil, it's great to see you.
Hi, good to see you.
Thanks so much for joining us. So why don't you give folks a quick intro, in case they don't know who you are?
Sure. My name's Phil Haack, as he said, and I am currently just kind of doing my own thing, consulting, writing code in my spare time. But I was formerly a Microsoft employee.
There you go. Okay.
A long time ago, I worked on ASP.NET MVC and NuGet. We were part of the founding teams for that. And then after that, I was at GitHub for just about 7 years, and there from when it was 50 employees to 950 when I left after the board bought it.
Wow. Okay. We're jumping right into that. Oh my goodness. I'm looking for an appropriate sound effect for that, friends. But you spent a lot of time, obviously, weigh in on developer tools, weigh in on helping make folks more productive, and not just source control with GitHub, but building applications, publishing libraries to NuGet, the whole developer lifecycle you've been a part of, but mostly for the last 4 or 5 years at least at GitHub, working with Git, and you really know how to use the tools and make that happen for folks.
I sure hope I do.
So the questions that come up on channel a lot and that we run into are around what are the best ways to start using Git, right? Folks that are new to source control, why do they need source control? What makes it so important? And I hold this belief that source control is something that not just software developers need. Because, right, you're managing just the state of files.
Mm-hmm.
So if we can get to managing the state, the versions of other things, everybody benefits, right?
Oh yeah, definitely. I mean, part of the problem that source control solves is twofold. One is like it gives you a time machine for your files, right?
Mm.
So like you can go back to any state in the past, and it's like, why did I make that change? Go back in time, look at why you made that change, and then that might help you figure out the problem. But the other thing it solves is helping people to collaborate with each other without stomping. I think we've all experienced this, often, especially working with lawyers, they like to send out those redlined Word documents. And so then you make some changes and then you send it out, but they've sent out copies to other people to review who've made their changes, and now you've got 20 Word docs and you have no idea which one is the canonical Word doc. And someone has to compile the changes together.
Yes, and they've all got everybody's initials at the end of the document name, right?
Yeah.
Important document _JF.docx.
Right, and what you really want is, and then there's all the formatting changes that get in the way. And I'm a big fan and proponent of Markdown. Markdown is a simple text format. Here you can see.
Let's go over to your
Oh,
screen.
yeah.
There we go.
Now you can see.
Hey.
So if you go to any GitHub repository, they'll likely have a readme.md file. The MD stands for Markdown.
Okay.
And here GitHub automatically renders the README on the homepage of a repository. So if I click on the readme.md, okay, it's still rendered, but I can go look at the raw file. Whoa, that doesn't. Or how about we just edit it? So
Okay.
I'll click the edit this file. And you can see here that it's not rendered now, but it's just this textual format that is pretty similar to what you would do if you were trying to only use text to convey a table or to convey
Sure.
a heading.
Right. I would do that in ASCII in an email.
Yeah, exactly.
Right. Back in the day on bulletin board services, those types of things.
Yeah. Way back in the day.
I'm showing my age, okay?
When the dinosaurs roamed the world, they would type in ASCII on bulletin board systems.
Wow, yeah. Wow, indeed. Oh my goodness. Okay.
Is that Owen Wilson?
Yes, Owen Wilson, indeed.
Wow. All right. But the point of this is that when you see the history of this file, you can go to any different version, and you get this nice, easy to view change, right? Like
The change history.
The change history.
Yeah, can you zoom that in?
Oh, sure. Ooh, ooh.
Yeah, there we go.
So, file bursts into drones. Yay. So this repository is actually associated with a book that I wrote with Sarah Guthos, who's now a Microsoft employee, called GitHub for Dummies.
Okay.
It's a shameless pitch. But the point is that we ask readers, as they're reading the book, there'll be a point in time where they'll go in and they will add themselves to this file.
Mm.
The other cool thing about this file is that, or GitHub and source control, is that you have this blame, or as some people like, who are more positive oriented, like they call it credit.
Yes.
But you can see who made any given change. So, for example, on this line, this was done by this person here, Hee Lee.
Okay.
But I made this first initial table.
Right.
And then this thing is cool because you can also click here and go back in time. So this is the change before I made that change to that line. So this is what it looked like before then.
Back in the day.
Yeah, and we can go further back in time. And now we're at the initial commit where we just started this readme.
Okay.
So you can do that for any code file. So let's pick a project that probably is familiar with people who listen to you. ASP.NET Core.
Yeah, of course.
I used to be on the ASP.NET team a long time ago. I really love what they're doing. But let's find some source files. So I'm going to look at the source folder. I'm going to pick security for no reason.
Yeah,
and,
we love security here.
Let's not look at a solution file. That's
no,
horrendous.
we don't want to do that.
We don't
Security,
want to do that.
we know, is all magic. Barry Dorans waves his magic wand and bring.
Okay, I picked a file that. Oh, this is not an interesting file. You know what? Let's pick a. I know what we can do. So we can hit T. So the letter T. That's a keyboard shortcut. So if you hit the question, here, let me escape that. So I'm kind of going fast, but if you're in GitHub,
you're fine.
And you hit the question mark,
yeah,
you get a list of all these keyboard shortcuts.
Oh wow!
And I highly recommend playing around with this because this is such a great way to navigate the site. So for example, I was looking for a file the hard way, clicking, click, 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 right? But now I can just hit T, and that brings up this file searcher. And so I know that there's something called an API controller.
Yeah.
That's it. So here, let's just look at contact API controller. Sure, we'll look at that. And now we've got, navigate right to that file and hit blame. And I can see who's making changes to all these different files. I can go back in time to last year and so on. Very useful way of navigating the history of code.
I like, right, that you can immediately see who changed each line, right? It's very clear right next to it. And is that the comment that was committed with that change?
Yes, that's right.
Okay.
So you can see, and you can, this is sort of the summary of the first line of the comment, the commit comment. But if you click on it, you can go right to the actual commit. So for example, this commit introduces a filter to send bad request results with details when model state is invalid, whatever that means. But we can see all the changes here. So for example, this minus shows you that this line was deleted.
Okay.
This plus shows that this line was added. And
it's showing you exactly where the difference is, right? Because it looks like it's a little bit bolder, right?
Yes.
There's a highlight there
right.
to help you.
That shows you the specific change. And you notice that this is an inline diff, which I've become a real fan of over the years. But I know that earlier, I was really into the split diffs. where they show the changes side by side.
Okay.
And so here you can see very easily that this is an addition. It's just that like in C#, class names tend to be really, really long. So like split diff sometimes everything's jammed
Being able
up
to
a
see
bit.
it stacked is a little bit easier.
Yeah. Whereas like, Rubyists, they tend to like really short names that are unhelpful. So, but the split diff works really well for them.
Okay.
I don't know, some of my best friends are Rubyyists, so
Hey,
I can say that. Yeah.
we're equal opportunity offenders here.
That's right.
Okay.
Yeah, I hear you love JavaScript.
Me love what? JavaScript? Where is it? Where is it? I know they're here. You know what? I don't see it here. Can somebody trigger that JavaScript sound effect? It's gonna fire?
Horses love JavaScript.
They do. They love the JavaScript, but I don't hear it.
Wah, wah.
I know, right?
We'll
Things
do
that
our,
I had
we'll do our
working.
own sound effects.
Right. No, we will. I will get that working again. I promise.
There's one more thing I want to note here.
Yeah.
That's kind of subtle. You'll notice here that this comment says fixes number 6789,
Okay.
and that's an issue. And GitHub links that text to this issue, right? So this is the original issue. Hey, we need to do some cleanup for Razor components. And what's cool about this is when you commit with that, and that commit eventually makes it to the master branch. So every Git repository has sort of the main branch.
Okay.
And you often do your work in a side branch, right? Kind of like a parallel timeline.
Right.
And then you submit what's called a pull request, saying, hey, can you pull these changes into the main branch?
Okay.
And when those changes get merged into the main branch, if you use this syntax, fixes number blah, 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 then when that commit is merged, it actually closes that issue. And
Okay.
notes that
All in one
go.
All in one action. Okay.
Yeah, and there's other words that work. You can say resolves instead of fixes, but
okay.
it's the same thing. And so if we scroll down here, we'll see that one of these commits, like I think it's probably this one, it's linked. So it's linked both ways.
Okay. So you can see from the issue, you can see the pull request or the commits that reference it. And then hopefully we can be able to resolve these things, be able to track them a little bit more closely. Thank you, Janescu.
Yeah, so it's so Git, like Git and GitHub, they're two separate things, but
they play together.
They play, yeah. GitHub builds a lot on top of Git, and then it links things together.
Yeah. Okay. Because when you manage a project, you're going to have issues, features, and then you want to correspond those two. You want them to make sense together. I see what you're trying to do out there, chat room. You're trying to get us to mix up here. So, okay, these are features on the GitHub website, the GitHub service. If I'm just getting started, if I've got an application, I've got maybe some text documents that I want to manage, I have to start doing that locally on my machine with Git, or can I just start up a repository on GitHub and just start posting files there like I might do with Dropbox or OneDrive?
So it depends what kind of files. Like if you're writing code, you're probably going to want to start with your environment. But let's start with the real basics, like just getting familiar with Git. So I'm going to go to my account, and we're going to create a new repository.
There's the horses.
Well, I guess we should do something with JavaScript then, huh?
Sure, we can do something with JavaScript.
Now we'll just do Fritz demo because I'm unoriginal.
Okay, that works.
Whoa, what happened there? We're back. Okay, so Fritz demo, and then wait, Fritz is already taken? Okay, so description. I'll make it public.
Okay.
So this is important. I can initialize it with a README, and I can add a git ignore. So if you are a Visual Studio developer, you might pick Visual Studio, and that tells Git to ignore like the bin directory, the obj directory, all the stuff you don't want in your version control.
Yeah, those common things that Visual Studio puts in to make Visual Studio work. Okay.
And this is a small thing, but one I'm proud of because I worked on this. Not the actual implementation, but a long time ago when I joined GitHub, everyone was like, oh, you need a license picker because so many repositories don't have a license.
Mm.
And when I ask people about that at GitHub, they're like, well, if we just put a list of licenses there, like how does anyone know what these things mean or what to
Sure.
share, right? Like it's almost irresponsible to do it if, like, because those who understand the license will know how to add it already.
It's the I am not a lawyer button. It's like, I don't know what these things mean.
Right. And then we just give you this choice, right? Like, do you know, like, oh, what medical procedure do you want? And I just throw a bunch of names at you, and you're like, I don't know.
Yeah. Okay.
So what we did is we created a site called choosealicense.com.
Okay.
And so this is what I worked on, because I was like, well, what if, you know, we created a site that actually explained these things in a simple manner. So, and I really wanted to focus on only 2 or 3, in this case 3, 3 key licenses. These are the licenses that are the most used licenses on GitHub.
Okay.
You know, there's
and these aren't specific to software. You can apply these licenses to anything, any content.
they're actually, so these are, they're generally are specific to software. If
Okay.
you're going to do like general content, you would actually use a Creative Commons license.
Oh, okay.
So that's a whole another topic. We, you know, I'm not a lawyer, yada yada. But if you click on the MIT license, you know, you get some information about kind of bullet points about it and
Okay.
the text of it. But anyways, with that, we felt that it would be, at least we've done a little bit of our due diligence to add a proper MIT or add a license picker, and then you can create, create a repository.
And this is a location on GitHub that I, as the account owner in your case, you own, and you can manage and put your code, put your files there.
Yeah. So one neat thing is every repository is under your username or your you can create an organization on GitHub, put it under there.
Mm-hmm.
And that way, like, you and I can both have a repo with the same name. Doesn't matter because it's going to be in our sort of namespace, right?
Okay.
But, you know, ideally, like, if we have a repo of the same name, like one's a fork of the other.
They're related.
They're related, yes.
Okay.
So fork is just basically a copy of a repository into your own account. But what's cool here is I can go ahead and create new files here. So let's program.cs and pretend I'm actually, that's in a preview. Public static main, void main, yes. String, I almost did string star, I'm not C# here. String args.
Yeah.
Like that, right? I wouldn't normally write code like this, but we're just playing around here. And then I know someone out there is like, oh, you forgot to use using system. And then also I need a class, right? Program. Here we go. This is how I like to write C# in Notepad.
Absolutely.
Yeah.
Because
60% of the time, it works every time.
it does.
Okay.
Okay.
So I've written this little program, and I can go down here and, initial commit. Now that's an emoji syntax, which isn't rendered here, but if I did down here, you can actually get the picker.
Okay.
So I
Nice.
love sparkles. Okay. And now I'm not going to commit to the master branch because I'm not an animal.
Oh.
Instead, I'll create a new branch, right? The programs.
Okay.
And then I'll propose a new file.
So the branching lets you work isolated from the master branch. You've
Right.
created your own place to work. Gumshoe Noir says instead of writing it this way, he prefers to use copycon.
Oh, right,
Wow.
right.
That's
That's like a Hanselman joint right there. Like,
That-
he loves to do that in demos, and I'm just like, you know what? No one really does this in real life.
folks don't remember that. They'll do echo with the pipes.
Yeah, echo with the pipes. But I can't do echo with the pipes on the web. So.
No,
But I like the idea. I like the way you're
we
going.
like the graphical user interface here.
Yeah. So I've already created a commit, but what's cool about this is when you're using the editor in github.com, it figures, well, you probably want to create a pull request. So I'll go ahead and do that. And now you see in the pull request tab, we have one pull request. It says, I love sparkles. So I have to configure this. Merge Droid is something that just came out, and it's with a company I'm advising, so, disclaimer.
Okay.
What this thing does is really cool. it will look at your pull request and compare it to the master branch and use a semantic diff algorithm to determine whether it can resolve a conflict. So it only triggers when there's a conflict, right? Like a merge conflict. So a conflict is, let's say, Fritz is also working on master, and he changes line 2 to something, and I change line 2 to something. Well, when Git wants to merge those two in, it's like, well, you changed it, he changed it. I don't know which one's the right one,
Sure.
right? But what if you were just adding a property, and I was adding a property? Those are changes that semantically are resolvable, right? One property should just go after the other,
Sure.
Doesn't matter which order. So what Merge Droid will do is, if there's a conflict, for the languages it supports, such as C#, it will try to resolve it semantically, and if it can, it will push a new commit to your pull request saying, this resolves that conflict.
Ah, okay.
Yeah.
Okay.
And that's really cool. So they have an assessment tool. Sorry to go off on this tangent, but I think it's really cool stuff.
So, I mean, right, here we go. Where is it? I'm going to go find that. Yeah, we're a little bit off squirreling here, but I mean, this is interesting in that, right, when you are collaborating, right, if we think about this outside of the scope of being on GitHub, right, if just two people working together and you're making changes to the same files, it's typically last one in wins because I made the change last. I overwrite anything that you were working on.
Right.
So, and Git tries to help us by saying, well, these are the same, there's a conflict here, you both changed the same place. Fix it. And this organization can help determine the best way to fix it.
Yeah.
Awesome.
And stepping back, there's a lot of these applications on GitHub. So if you go to github.com/marketplace, we'll get to Git, by the way. Like I just
it's coming.
Starting with GitHub, yeah.
Sure.
There's all these different apps, right? And so you can have linters, a static analysis, code review tools, yada yada.
Thank you for
That's
the
right.
follow.
Yep. Where was I? So you can install. You can install all these apps on. Where is my repo? Oh, there it is. You can install all these apps that can do all these different checks.
Yep.
And when you click details, it goes to this checks page right there. You see the tab there?
Yeah.
And gives you more information about what this particular app figured out.
That feels like that was not brand new, but it was recently added in just the last few months, that checks page.
Yeah, it's relative. It's very new. Yeah, and GitHub just announced the version 2 of GitHub Actions.
Yes.
So you can now add CI/CD, continuous integration, continuous deployment, without having to set up an account in some other system like Azure Pipeline. So it's all built in to GitHub now.
So you can trigger all these things to inspect and work with whatever files you've changed without actually doing anything. Let GitHub trigger those other services. They go do their things, inspect your code, inspect your files, submit changes through commits or something, and then I can take action on it.
Right, because right now, I've got this code here, and I was like, I can review it. What about R, right? And
Sure.
I can start a review. But not a lot of people have used the review features because it used to be you could only comment, but now you can do review so you can see it's pending, and then I can click over here, finish my review, and say, hey, you need to, please make some changes, and pull request, so it's telling me pull request authors can't request changes on their own pull request. Yes, okay. So I can just, fine. This is public, so someone else can review my code. But here's the thing. I'm looking at this code, I'm trying to review it, but I don't know if this code compiles. I mean, it looks like it will. I don't know if there's any syntax errors, looks fine to me.
Looks legit.
Yeah. I think there's a problem that this is on its own line, and I'm more of this is on the same line, and I'm more of a on the own line when I'm doing C#.
Yes.
On the same line when I'm doing
your code formatting.
JavaScript.
Yes.
And then so the thing is, you don't want to put all that effort onto human reviewers, right? Like to worry about the syntax and worry about
Does it compile? Does it pass the test?
Does it meet our style guidelines?
Yes.
That's all a waste of your time as a reviewer.
Mm-hmm.
Let's let the computers do that. Let's let let's put the robots to work. Right?
Absolutely.
I mean, at least until they take over, we can put them to work for us. And so they're the ones who can kind of do all that analysis through these apps, so that you can spend time focused on your actual work.
Yeah, the actual business value of what it is that you're delivering in those files. Some code, some markdown documentation, whatever it is. Let all the other stuff that we can quantify and we can measure, let the machines do that.
Okay, so at this point I'm satisfied with this. I'm just going to go ahead and merge it, confirm the merge.
Yeah. Okay, and it says in purple merged up there, all right, and delete the branch.
That's just a habit I'm into. Like
Sure.
once you've merged it, the branch doesn't need to stick around.
Okay,
I think they just announced there's a new feature where like they'll auto clean that for you. But
good.
now that we're here, I go back to the main and you can see that program.cs is now part of the repository.
Mm-hmm.
And did you notice that like my little emojis rendered in the commit message now?
Yeah.
That's great. But okay, this is not real world because what I'm really going to want to do is work on this code locally, right?
Sure. Sure.
So
Bring it into Visual Studio Code, be able to run the compiler against it, all that stuff.
So the typical way to do this is you go to this clone or download button. You have this clone with HTTPS question mark.
Mm.
So, or you can use SSH. I highly recommend, and GitHub does too, just use the HTTPS. If you don't know how to set that up, it's usually set up for you. But if you have issues with it, like how you have to set up a credential provider.
Yeah.
But especially on Windows, it's getting easier. The Git for Windows already comes with one.
Yep.
That knows how to authenticate with GitHub. There's a feature I added.
Nice.
So I'll hit the copy, and then we'll go back to the shell and type.
We need to bump up the font size there. Stelzy has a question in chat asking, is there a setting to not automatically delete a develop branch when merging into master?
Setting to not automatically. Yeah. So this develop branch, let's assume, is a. This is a great question. So I tend to subscribe to something called GitHub flow, right?
Mm-hmm.
Where the master branch always represents what you're deploying, and then everyone creates little feature branches and then merge into master, and it's a very small, tight loop.
I love doing that on stream as well. Folks that are watching, you've seen me do this as well. I've got feature branches named feature underscore whatever it is I'm working on.
But there's a Git flow that is a little more complicated because often it has not only the main master branch but also a develop branch.
Yes.
And this is a persistent branch. So when I'm coding, most of my branches are not persistent, right? Like a little bit of code, merge, really tight loop because easier to understand. Like if something goes wrong, you don't have this long, very long branch.
A very long list of changes. Thanks so much for the subscription, Carrie. It's Carrie Payette, 8 months with us. Thanks so much. We really appreciate that. And I'm going to make a donation to Coder Dojo this quarter. Thanks so much. Yeah.
Did I ever tell you my brother learned how to code from Coder Dojo?
Really?
Yeah.
Oh, that's terrific.
Yeah.
They're helping folks all around the world. They're training trainers and building facilities.
Yeah.
Cool
Great.
stuff.
Well, anyways, so dev in this case, I assume, is a long-running branch.
Yeah.
And in that case, you don't want to delete it when you merge it in master because like people are going to continue working on there. So what you do is you go into your settings here.
Okay.
And you go to branches.
And this is the repository settings,
The repository
not my
settings.
preferences. Okay.
Right. And you have these branch protection rules. So you can also change the default branch, right?
Mm-hmm.
So you can make dev the default branch. That's one way to do it. But then someone can delete master. Or you can add a rule here, and you can say branch name pattern, or you could just say dev.
Mm-hmm.
And you can add these different rules to it. So you can require pull request reviews when merging. So if someone can't just merge that branch, you can require status checks. You can require signed commits and include administrators. And or if you leave it on unchecked. Okay, don't look, everyone.
I can help with that.
No, don't worry. It's not
You're
going to
good?
show it. Yeah.
Okay.
Okay. So I use one password for that.
So,
Okay, so save changes. So, branch.
right, we don't have a dev branch right now.
Oh yeah, that's the problem. So I can't create a rule for a branch I don't have. So I'll go over here, the create branch dev.
Okay.
Now let's go back. Let's try that again.
So what you're doing, right, when you have a dev branch, the practice that I've been showing folks on stream that I
Oh, here it is.
that I show. There we go. Is I have a master branch and I have a dev branch, and all our current work is going on in the dev branch, where master is production. That's what we're deploying out, and we're saying this is real. But anybody can write code against dev, right? We want to
Yeah.
protect master. We don't want pull requests to go against master. So feels like I need to create some branch protection rules to ensure that we don't get pull requests going against master if master is the production area.
Yeah. So let's test this out, right? Like I
Okay.
believe this will work, but I've actually never done this, so this in this way. So we're gonna switch to dev.
Brand new, okay? We're going to make sure that everything works here.
I love it when a plan comes together.
I do. I love it when a plan comes together.
Actually, you know what? Why don't we go back to what we were doing, and then we'll use this as our scenario, right? So
Yeah.
so I could git clone, and then let's see, I could copy this URL.
Which is hiding behind us there, but that's okay.
Yeah.
Thanks so much for the resub. Dev lead, 1 year with us. Congratulations.
All right. But I want to show you another way to clone, just
Okay.
because this is a product I worked on and I really love it. So if you go to desktop.github.com,
Okay.
you can install this client app. And so a lot of people are like, oh, I just use Git on the command line, and same here.
Yeah.
I'm a command line junkie.
I've
But-
been using it forever, so that's where I am.
But this thing is great because it has some things that you don't get. Oh, that's my secret project. Okay, let's do this. So I'll do GitHub dot. Oh, wait, let's see. I haven't cloned yet. Oh, I should. Let me go back.
Okay.
Where am I?
Yeah, that's right, Dev lead. Your 12-month subscribers get a propeller on their hat badge in this channel. Absolutely.
So if I click open in desktop, it'll prompt you to open in GitHub Desktop, and I can always say, yeah, always use that.
Okay.
And then it launches GitHub Desktop using a URL protocol handler. So you don't even know what that is, just that like it responds
It's
to that-
registered, so it knows this is the type to open.
Right.
The application to open that type.
And then exactly, developers.
Developers know this.
So you can choose where I want this to go. I kind of want this in my dev folder. There it goes. And it's going to let you know. Wait, why did it? Local path. Oh, that's right. Okay. And then I can hit clone.
Okay. And while that's cloning, I want to thank Relevant Jesse. Just rated the stream. We got about 12 viewers to come over. Looks like there's 39 others out there. I'm not quite sure why the audio is only in the left channel. We've checked out our soundboard here, and everything looks good. We'll edit things down, and we'll rebalance for the recording. Thanks so much for joining us, Relevant Jesse. Let us know in the chat room, what were you working on over there on your stream? And welcome, Raiders. This is my guest, Phil Haack, today, and we're learning a little bit about Git and GitHub here. All right.
Okay, so now you can see that this demo, this repository
That code is local here.
is now local, right? And I can use this to work on it. Or I can do the command line. So I'll kind of show a little bit of both, right?
Okay.
So let's use he did code dot, which is launches Visual Studio Code, and you can see here's my.
There's a little source code file that you wrote.
Yeah, and I might want to give it a namespace. Fritz demo.
Okay.
Okay, take that.
We put the extra curly brace at the end.
Yeah. So I like VS Code okay, but I wish it would do the little indentation things like you get in Visual Studio proper.
Yeah.
I started using Writer recently. I really like that on the Mac.
Okay.
Yeah, It's funny. When I was at GitHub, just about everyone at GitHub, all the developers used Macs, and I used Windows the entire time because that was my target audience.
Okay.
Bring GitHub to Windows developers. And then when I left, I was like, okay, I want to get a MacBook finally to see, what all the fuss is
What's so
about.
great about it?
I hate it.
Oh!
Actually,
Oh, you did not just go there. Really? Oh.
actually, there's some things I really love.
Okay, go ahead.
The Touch ID is really nice. Just so much. I know you can get add-ons for a lot of the Windows laptops, but like everything just works. That I really like. In fact, and I also like that it's a proper Linux or Unix operating system, so that when I was running these apps, sometimes they wouldn't run on Windows. Now I know Windows has WSL coming, WSL2, but WSL1, like I had things I was running that wouldn't work on it because it didn't implement all the different hooks. WSL2 will be a full, Linux operating system. So
Yeah.
But yeah, again, I digress. But anyways,
So we've got a suggestion here. GS Volt in the chat room is suggesting try Control-Shift-I to auto-format the code in VS Code.
Control
probably-
Shift I. Well,
Well,
I've already formatted.
they've
Okay,
already done a little bit of that.
Yeah, let me try that. Control Shift I. There's a Command Shift I.
Might be Command-Shift because you're on a Mac.
Yeah, that's true.
I don't see a change.
Okay. Yeah.
No.
Okay, we'll play around with that later.
Yeah.
See, that's why I don't like Mac.
It's right there.
It's right there.
Speaking of GitHub Desktop, President Notcher has a question about GitHub Desktop features. Does it have an interactive rebase? We haven't started talking about rebase yet.
Oh yeah. You told me to keep this 100.
I know! They're diving right in. My goodness.
Oh, interactive rebase. It does not yet have an interactive rebase feature. I believe it's on the roadmap. I no longer work on the project, but you can go to, it is open source, and it's hosted on GitHub, as you might expect.
Very nice.
GitHub.com/desktop/desktop.
Desktop.
Yep. So they have more orgs, and so, wow, 521 issues. And I bet if we did rebase, we'd find 28 open. Let's see. Let's try interactive rebase. I'm just curious.
It's okay, President Not Sure.
Okay.
We're happy to answer questions as they come along here.
Oh yeah. I mean, I shouldn't say this, but I showed up completely unprepared, and he just pinged me today about what time to come over. So I'm making this up on the fly in real time.
Everything's live.
Okay. So let's. So we're back to Git.
Yes. Okay. So Git is what
if
we're
there's another
using.
question, go ahead and interrupt. But,
Okay.
So we're back to we'll play around with the command line a little bit, right?
Okay.
So we can type git status, and we can see that, I modified the program.
Yeah.
Oh, but I'm in the master branch. I don't want to be there, right? Because I'm, what did I say earlier? Not an animal.
Not an animal.
So we're going to git checkout -b dev.
Yeah.
Okay? So we switch to the new branch dev, and then we'll git add program. So this part is a little confusing for a lot of people. So who are new to Git.
Okay, so git checkout -b dev. It says it switched to a new branch dev. So that checked out the current state and created a new branch.
Yeah, and it did two things in one command, so that's often confusing. So let me just git checkout master. So git checkout is how you switch to a branch. So git checkout dev. But if you want to create a branch, you just type git branch foo. But it doesn't.
It didn't move you into that.
It didn't move you to the branch, right?
Okay.
Git branch. So
it reports the ones that are currently available.
Yeah. So I can delete foo because I don't really want it. So if you want to create it and switch to it, check it out. You do the checkout -b.
Okay.
Now, I do a thing where I create aliases for a lot of these common patterns.
Okay.
So if I want to create a new branch, I'll do git cob checkout -b. Yeah.
Okay.
I need a better name, but cob works for me.
That's kind of corny.
And yeah, corny. So git cob corny switched out. We can get into git aliases later, but I have some very powerful git aliases.
Yeah.
And if you go to hacked.com, and just do a site search for Git aliases, I have this blog post with 13 aliases that I've written, and including a 14th alias. And like some of these are really interesting. Like, I'll talk about the Git migrate. So imagine that I've told you already, don't commit to master,
Okay.
do your work in a branch, right? Now, yes, some workflows, people do commit directly to master, that's fine. I'm not, trying to harp on them. But if you're a person who's like, yeah, I always want to work in a branch, but you've been committing and you look and you're like, oh no, I'm actually on master, shoot, what do I do? So you type git migrate new branch, and then what it does is it looks at your local commits on master, reconciles them with what's called the origin or the server. In this
Sure.
case, it would be GitHub.
Mm-hmm.
And then it takes all the commits that are new and not on the server, and then it moves them to a new branch, and then resets master back to the origin.
Oh.
So basically, it's kind of like taking those commits and moving them to a new branch. So now your master's back to the way you wanted it.
Okay.
And you saved all your work in a new branch, and now you're on that branch. So this is an
Interesting.
alias that will do all that. And it saves you a few commands, right?
Sure.
Anyways, I recommend it. So let's get back to dev. So there, I also alias CO for checkout. So, and we're gonna add program. Oh wait, I already did. Git status. Okay. So committing a file is a two-step process if it's a new file.
Right.
First, you have to add it to the index, or you have to add your changes to the index, and that's that.
There it comes. Thanks so much for the follow. Is that Dark Comet? Appreciate you joining us.
So git add adds the file to the index, doesn't actually add it like to the remote repository or to the repository as a commit yet. And then you can do git commit, and that launches your registered editor to write a commit message. Or as a shortcut, you can do git commit -m, and you can type a commit message right here in the console. Let me switch. I hope that's not too hard to see. Git commit.
No, you're good.
Add a namespace. And then I can type git push -u origin/dev. Or actually, I think git push might just work. Let me try that. No, okay. So this is where things get. Some tools will, if I had used Git Desktop to clone the dev branch locally, another benefit of the desktop app, it would have automatically set the upstream branch. So every branch that I have locally has a corresponding branch upstream. So what I need to do is -- set upstream origin. So
Right,
origin
so-
is the name of the where it's hosted,
Right.
and then dev.
So this is an important concept. What you're working on locally is actually separated from what's on GitHub. We've got two
Right.
different instances of our repository, and they're both Git repositories.
Right. And this is where we get into the distributed nature of Git. And this is the part that trips a lot of people up who are used to Subversion or, God forbid, Visual Source Save back in the day. Dinosaurs, the source control for dinosaurs. But you can have multiple, so these repositories are all distributed, right? So like I have my local copy, there's my copy on GitHub, but I could have another copy on some other machine. And your list of copies are called remotes.
Yeah.
So if I type git remote -v, I can see that I have one remote named origin, but it's associated with this URL for both fetch and push. You can even have different URLs for fetching and different URLs for pushing, but that gets real complicated, and I wouldn't advise it. It's hard enough to keep track of one. But the reason why you might have more than one remote is, let's say that I actually want to contribute to a project that I'm not a member of, right? Ethnet 4. So I might go over here and fork it. Oh, I've already forked it. Okay, so I forked the home repository from
Okay.
days That's weird. Why that? Anyways, I must have named it wrong. But I forked this repository. So if I clone this,
Mm-hmm.
I'm going to clone it to home. That was fast. Okay.
Nice.
Let's go back. Let's go check out home. Git remote -v. Now you notice here there's two remotes.
Yeah.
So origin is sort of my copy of this repo on GitHub, but upstream is the copy from the original source of it.
Yeah.
So this is where, like because I don't have write access to ASP.NET Core, I can't be pushing to it. I can only be pushing to my copy, but I can be pulling from upstream. So I might want to get the latest changes from upstream by git pull upstream.
So, yeah, Space Shot in the chat room is hinting at this. This is where it gets a little bit tricky, synchronizing those three repositories, the upstream, the origin, and your local.
That's right. So my trick to that, and I wish that there were, I could actually create some aliases for this, but my trick to that is that when you are working on a repo where it's a fork of another repo that you want to contribute to, this is another reason, never work in master on your copy. Instead, just, repeatedly go to your master, the one, your copy, pull from upstream into that master, and then occasionally pull the master and, like rebase your own branch against master or pull, merge master into your branch or whatever.
Okay.
That way, the master of your copy is always up to speed with the master of the upstream.
Of the where you're working from. Okay. So let me kind of repeat that, but make sure that we understand. So if we're working on a shared project together, the home in this case, I want to make sure that my local copy mirrors what's and
the master branch of your local copy.
Right. My local copy's master mirrors what's on the shared project's master.
Exactly.
Okay. Then I can work on something that when I branch from master, I'm working on something that's a branch of what was shared.
Correct.
Got it. Okay.
Right. And as you work on your branch, right, you might make changes. Occasionally, you may want to pull upstream into your master because they're working on that too, and you want to, resolve your changes with whatever they're doing. And that is the one situation where, like working locally, I would definitely rebase. And so rebase is yet another.
It's another, yeah. We've got a little bit of time we can get to that.
Let's get to that later. So I went on a digression again. I'm known for that. But let's go back to Fritz.
Yes, absolutely. We can. There goes the squirrel again.
Okay. So we're on the dev branch. Did I push this yet? Yep. Okay. So now let's go. So I have another alias, git browse, and this will actually bring us right to the repo that you're in. And you notice here when I push this branch, it notices recently pushed branch is dev. So I can click here, create a pull request, and then let's create this pull request. Let's see what happens when I merge it. Checking for ability to merge. Okay. And notice, no delete button. So all of that was to answer that question.
No. Gosh.
But in doing you learned a little bit about the workflow, right?
Yes, absolutely. So, okay.
So hopefully that answers your question. I forgot who asked it, but it was a great question.
Yeah, gosh, that was a while ago.
Yeah. So that showed, and some of these features, they're relatively new and not well known for people, especially people new to GitHub, like branch protections and stuff. But you can even do, what's cool is you can do wildcards. So if you have a whole pattern for like dev-star, you can do that, and any branches prefixed with dev-star will have whatever rules you apply to it.
Okay, in case you might branch if you're dev for the next version of the application.
Right, exactly.
Okay. So dev for version 3.0, version 4.0. We don't use 4. 5.0, right?
Yeah. So we went into the whole upstream and all that, but when you're working on a repo that you're a member of, then it's a lot simpler because you don't have to worry about that, right? You only have to worry about the one origin, which is GitHub.
Sure.
And one of the things I'm seeing, I won't say a lot, but some open source projects are starting to move to a model where, like, as soon as a person submits one PR, they add them to the collaborators list,
Okay.
so that they have permission to go ahead and push directly to the repo.
Oh.
And then they use branch protection rules to make sure that, like, they don't push directly to master.
Okay.
And that, in a way, like, it's, it feels riskier, like I'm just giving everyone access to it. But, like, people who, like, contribute and have their work accepted tend to be much more careful about it because they don't want to lose that privilege, and they feel very honored and appreciated, which I think any maintain. And plus, as a maintainer, like, the number of people who are actually going to contribute once, much less twice, is very low. So if you can make reduce the friction to becoming a regular contributor to your project, it's worth taking the risk of being very liberal with the amount of permissions you give people.
Ecomath is saying Gatsby. Does the Gatsby project do that?
Exactly. Gatsby is the one who is one of the ones that comes to mind who does that.
Very interesting.
Yeah, and it's something that I think I want to do for my open source projects. It's like, hey, if you want to contribute, I'll just go ahead and give you access.
Yeah. So the crawl that you see going across the top, that's a combination of some news from the .NET community, from Discover.NET, and there you go. See the Stream Tools project go by. Nobody's contributed to that this week, but you see the list of folks that have contributed to our to the GitHub projects that we work on here on Stream. So there's my Stream Tools project, which has widgets and things in there like our bot, the sentiment number you see down there, and even that crawl itself. That are all built with ASP.NET Core, and folks have contributed to. So I want to recognize and celebrate those folks. We didn't write any JavaScript in these, okay? We didn't. But there you go, the Stream Deck toolkit we were working on, the Stream Deck emulator, and I think we should also see go by their things for the resource management Blazor project as well. So, okay, we know a little bit more now about branching. We know the relationships between the various versions of and instances of those repositories, whether it's local or it's your own private copy on GitHub that you've forked. Right, so fork you saw was that copy from the shared project. Mm-hmm. Managing those three instances, right, and that pull request, right, being able to manage those three states, I feel like there's something there that I struggle with, and it's around this concept of squash and merge.
Oh yeah.
So let me explain this scenario and we can talk about this a little bit. So when I bring down and I'm working on that shared project, I'll make a couple changes, I'll commit some code, make some more changes and commit that code so that I have those checkpoints, because I'm going to mess up and I want to be able to roll back. I want to be able to go back to a previous version if I need to. But when I go to submit that, when I want to put that into the shared project, I only want to put one commit. I've got 3 or 4 of them locally, but I only want to really send one because it's one commit that I want to make available for everybody. So there's that squash and merge feature.
Right. In the pull request.
Yeah. Right. So I create the pull request and it says, oh, here's your 3 changes, 1, 2, 3, and I'll squash and merge those. What does squash and merge do? I mean, it sounds simple. It squashes and merges. Okay. But how do I ensure that my repository is clean and in sync with what's now in the shared location?
Yeah, so one of the other things you'll notice about the Git community is that there's a lot of different philosophies and approaches to Git. So not everyone subscribes to the I just want to submit one change, because if it's a big change, people might want to be able to walk through your work even after it's been merged.
Sure,
right?
sure.
I will say one thing that's almost universal, though, is keeping each commit like sort of a semantic whole, an atomic unit that makes sense. So you don't want to have a commit that has a bunch of different unrelated changes.
Yes.
And there's a very practical reason for that. It's not just about like cleanliness and craftsmanship, which like some people are like, I don't care about that. I just want get it done, right?
Oh my
That's
gosh.
why it's called Git.
I don't have that clip. I
Get
need
her
that
done.
clip. Yeah.
But if there's a feature of Git, it's a little bit more advanced, but very useful. It's called Git. Oh my goodness, it's like a binary search for a commit that changed the behavior of something.
Bisect?
Git bisect. That's it.
Yeah.
Oh, my brain just lost it. So Git bisect is one of the reasons why you want a nice history. So imagine this scenario, right? Like, oh, you're testing your app and there's this bug, and you look at the last work you did and it's like, oh, I didn't change that code. So you're wondering which commit introduced that wrong behavior. So what you can do is you can type git bisect and then start, and then you specify a commit where it's known to be bad, the current commit usually.
Yeah.
And then you specify the last known good commit. You might have to go back in time, but you just specify it.
Sure. Okay.
And then what happens is bisect will start checking out commits in the middle, and then you tell it, is this good or bad? And so you test the app. And you say, oh, git bisect good. Then it goes to the next one, and it's a binary search. What's really cool, though, is you can also give git bisect a script. So you could tell it, run this script and on each of those commits, and it will automatically, go do the search, and then it will report back which commit was the one that introduced the new behavior.
Oh, very cool. So
it's a
I could
great
run
way for debugging.
I could, as a .NET developer, I could run a .NET test on every one of those commits that it's testing.
Right, exactly.
Okay.
And so this is one reason why I tend to like, I don't squash a whole lot.
Okay.
At least not like a pull request squash, right? I might squash while I'm working locally and merge and rebase and all that. But once I push something up to GitHub and it's in a pull request, I like my commit somewhat small and atomic because at some point I will write a bug. I know it's hard to believe.
Bugs happen.
Yes, I will write a bug, and Git bisect will help me find it more easily if the surface area of every commit is relatively small, right?
Yeah.
If all your commits are big, then like even when you find the commit where the bug is, you still have a lot of code to look through to figure out, okay, how was that bug introduced? So that's but let's go into merge and talk about what exactly is a Git merge, right? A Git squash. So I'm gonna add a file foo.cs. Do I have a code open? No. Okay. Let's just,
Oh yeah, it's there.
okay.
Yep, Enrich. That's a translucent terminal.
Yeah. And then let's git add foo. So I actually have this nice git cm foo.cs. Oh no, git cm test. So this alias basically adds everything, emits it with your
With the message
with
that
your
you
message.
specify.
Yeah.
Okay.
Touchbar.cs, git cm touchbar, being very unoriginal. So if we, so these two commits are local.
Okay.
Um,
They're not.
oh, whoops, what did I do? History. Oh, here we go. So we have one commit test bar, another commit test here, right?
Mm-hmm.
Now I could, let's push these. And then let's create a PR for it. Create a pull request. Create a pull request. So I'm kind of just ignoring what I would normally do with the descriptions. So here we see that I have a pull request with two commits, right? Test bar, just like we saw locally.
I just tried changing the sound setting there. Friends in chat, let me know if that sounds better and you can start hearing us in the other channel. All right. Okay, so you have two commits now. There we go.
Yeah, so I'm looking at these comments. Git bisect that runs tests might be really interesting to get in the toolbox. Yeah, When I was at GitHub, I started a project called GitHub for Visual Studio, and it's actually now like part of Visual Studio.
Yeah, it was integrated. It's now a feature.
Yeah, one of my dreams, sort of the stretch goal, was to build a feature in GitHub for Visual Studio where you could select a unit test and say, run this test with Git bisect until it fails.
Yes.
Can you imagine how amazing that would be?
It just like we have the the automated unit testing, the continuous unit testing that runs, right? Be able to have that run across your commit history. That is pretty powerful.
Yeah, not easy to. I imagine it wouldn't be easy to implement. Like there are many ways it could break down, right? Because
Sure.
you check out a commit that doesn't have a dependency that the current version of the test. But for a lot of tests, you could write a simple test, and it could. Visual Studio knows all the information to like say, okay, just keep this test over time, and keep running it until it fails or until it passes, whatever.
Sure.
So
keep that in memory.
I mention that because I really hope the Visual Studio team does this someday, because I think that would be a game changer for like using Git bisect and figuring out.
Hey, chat room, can you do us a favor? Help Phil out. Can you clip that description that we just had there, and we'll share that out on Twitter to some of our friends on the Visual Studio team, because I think that's a pretty neat idea. We'll see what they think. Thank you.
There we go.
This is pair programming with our friends out there watching on the internet.
Right. We'll bug the people in charge, right, Amanda? So I'm sure she'd love that.
Some of them might be watching.
Yeah. Okay, so here we go. We got the merge button, and what merge does is so imagine you have your two timelines, right? You got your main branch and you got your dev branch.
Sure.
A merge just creates a new commit that up here that reconciles the changes in both, right?
Okay.
And now, so you still have the branch, and it's just and all your commits, and it's just a new commit. You can also do a squash and merge. So what that's going to do is combine those two commits into a single commit, and then also still create the merge commit. So when we do that, confirm it. When we go back to the main branch, let's go back to commits here.
So it shows 6 commits.
So we can see here that merge pull request.
And there's dev, the one you just added,
Is that the commit?
with the 2 files.
Yeah. So you can see here that it created a dev number 4 test bar. So it combined the 2 commit messages into a single commit message, and it added the 2 files. So basically, it just took those 2 commits and merged them into one. And what I glossed over is it gave me an opportunity to fix the commit message, because like maybe I don't want them to just merge the two.
Sure.
But
You want to be able to clean it up and say, clearly, here's what these are. Frank's asking for the link. What link are you looking for, Frank? Let us know in the chat room. We can help out there.
But what's nice is if you go to the pull request, you can still see the original 2 commits. So it was just merged and squashed into the main branch. This is because like every pull request has what's called a Git reference associated with it, so that it can keep sort of the original history around as well.
Ah, okay.
So that even if you do squash and merge, that's fine.
The originals are still there.
Yeah. But we probably want to talk about squash and rebase, right?
That's another one. Yeah. So squash and merge, all the commits are hidden, and you get one commit that occurs in the final branch. Okay.
Let me just make sure that we're up to speed here. All right.
So, well, actually, here's the first problem. Here's where I run into an issue, Phil. Help me out here.
Okay.
You just squashed and merged into the master from dev.
Yep.
If you pull back that master branch into your local repository here, right, you're not going to get the same commits that are in dev. You're going to get the merged commit.
Right. That's right. Yeah.
So how do I update my dev branch so that it looks like the master branch and lose those other 2 that have been squashed?
Yeah, so squashing and merging isn't a great thing to do if you have a long-running branch.
Oh.
Or you need to squash and merge it in your dev branch before you do it, right?
Okay. Okay.
So let's check out.
Oh, you're killing me here, man.
Because squashing
Oh.
changes the history, right? So
Yes.
you bring up a good point. GitHub dot. Let's look at the history of this.
Right, because then
We
you
still
end
have
up,
the 2 original commits, right?
Yeah.
So here's one way you can do this. This isn't great, right? Is git reset master hard.
Okay. So that's gonna.
So now
Okay.
that resets dev to the state of master, and the -- hard means like, hey, don't worry about any local changes. Generally, be wary of doing that. And now you can see that I have the commit from master. But git dev on upstream. Let's go back to the dev branch here.
Right.
Let's see what this has, right? See, this still has the original 2. Now I have to
Yeah.
do a force push.
Oh man.
And when you do it, so what a force push does is it says, hey, I don't care what's on there. Like, override it with what I have locally. Now,
I'm the source of truth. I'm the authority. Take what I'm telling you
right.
is up there.
Oh, but I can't force push because we protected that branch.
Oh man.
But now you're in this weird state where anyone working on dev is is not synced up to master.
I'm gonna completely freak out at that.
So
Okay?
this is another reason why if you're using long-running branches, so this is not a problem if you're using short-running temporal branches,
Okay.
right? Because you're going to get rid of that branch after you merge it anyways. But if you're using long-running branches, you don't want to use that squash and merge. You can disable those buttons too for a repo. So you can just say, hey, look, we don't allow that sort of thing here, right?
Oh. Okay.
Let's see, where I forget where it is. I think it's in options here. Here we go.
Oh.
So
look at
in
that.
options, you can say we're not going to allow that. We're not going to allow that because this just causes problems. So let's say you're working on dev. You really do want to squash it.
Yeah. Oh yeah.
The way to do that is to squash it locally before you ever push.
Okay.
So git let's touch let's create an echo foo into foobar.cs and echo baz into flux.cs. In case anyone wants to know what the fourth metasyntactic variable is. I can't even say that word.
What is the force?
I think it's foobar baz quux, something like that.
And now we know.
And knowing is half the battle.
Exactly.
GI Phil. There you go.
Okay,
All right.
so-
I'm sorry.
Git add foo, git cm, git commit -m foo,
Okay.
git add bar flux. Fuck. Git where am I at?
No. Get
I don't even know how to type. Okay.
fingers.
Git add flux. There we go. Git commit -m. Add
So
quackers.
git commit -m was what you alias to that git git
CM.
cm.
That's right.
Okay.
That's right. No, except git cm adds all the changes.
Oh.
So I wanted to commit each one separately.
Okay.
So that's why I had to revert back to the full command
Okay.
because I didn't want to add everything because I want 2 commits, right? So git log session. Yeah. So these are the last 3 commits, right? We got add quackers, foo, and then that ugly squash.
That
one.
merge. Yeah.
So what I can do here is if I want to I want to squash it, I'll do an interactive rebase. So git rebase, this is where everyone gets really freaked out. Git rebase -i,
Yeah.
and then I'm rebasing against master. So let me pause here for a second. What this means is it's going to take a look at the commits on my local branch and how the ones that are not in master,
Okay.
or the ones since I deviated from master, because I forked from master. And then it's going to list them in my code editor.
Mm-hmm.
And so we see the 2 commits that I created. And now this is a really high-tech interface where I just go in and edit this, and I can say S for squash. And that means you can see down here, squash equals use commit but meld into the previous commit.
So
I'll
it's going to merge those 2 commits together.
Yeah, so I'll save that, and when I close that file, now it's running through so I gave the rebase instructions. Here's what I want you to do.
Okay.
Now it's actually running those instructions, and I only gave it one instruction, squash. So it's now squashing, which is, here's where I get to edit the message, and I can just say add foo and quackers, because Git makes me quackers. And now I save that, close the file, and then it went and did all that work. So
Okay.
now let's use Git Desktop to look at the history now. So now you can see that instead of 2 commits, I had this 1 commit.
Right. The other ones have been removed.
Yeah. So it took the 2 commits and squashed them into 1. So squash is appropriately named. Squash them. All right.
Yeah, so that makes sense to me, and I like that you did it against master so that you could see exactly what's changed between the two. Now, can I also do that against the upstream branch or against the origin version of the branch?
Yeah, absolutely. I mean, you can do it against any branch.
Okay.
So
I could do that not just against master, but I could have gone against origin dev.
yeah.
So that when I go to set up for that pull request, I'm only pushing up to GitHub the one commit.
Yeah, Git branch. I don't remember So one of the things is every branch, often if you're working with or remotes, every branch sort of actually has 2 branches, right? There's there's your local branch, and then there's the upstream tracking branch.
Okay.
And so you can actually access the tracking branch. So I could have said, let's say I had an upstream here, right?
Okay.
I could have done git rebase -I, and then I could have said upstream /master.
So here's what I'm going to do. I'm going to jump onto GitHub on my PC here, and I'll actually run over to that same repository that you're working on.
Oh yeah, because you should. Well, you'll have to fork it.
And right, so there's Fritz demo, and I will fork. And I've got way too many organizations. Now, we know you can't see what I'm doing on this, but what I'm going to be able to do is now I have a version of the repository that we could push and pull back and forth if that's the master or
Oh yeah, we
whatever
can get
other
real
name.
wild here. So what I'll do is after you fork it, I'll add a commit to master,
Okay.
but you just go ahead and branch and do your changes.
Okay.
So you've already mastered that.
Right, so I have a master branch over here. So if I create a branch over here, I'll call Fritz branch. Right, and if I do something that looks like this, right, and I can have right, and there's something that occurs in this file that I'm writing over here, and I'm going to commit a new file into this branch, but I put it into my branch called Fritz branch,
Mm-hmm.
and I'm going to share that location into chat. There we go. Okay. So there's this location that I've created, and it's not in your version, but it's in mine.
Mm-hmm.
And I would set up a pull request to send it over to you
Mm-hmm.
normally, right? I mean, I could add a couple more commits here, right? Or
Mm-hmm.
but I want to send this over now into your dev branch.
Yeah. Should we show your machine now?
So I would have to redo some cables
Oh.
here. But we can do that. It is possible. We can go back to
We have the technology.
there, right? And if we take there's the cable that you're currently plugged in with, the HDMI over here.
Oh, do you want to take that?
Yeah, send that
There you
over
go.
to me.
So I'll read these while you're doing that.
Yeah, go ahead. Read what's chat up to.
Commit refactoring some changes and make the first one.
And And there we are. That's what we look like.
Yeah. So, that's a great question. I'll show that. I should show that later. So, if you want to amend the most recent commit, git commit -- amend will do that. But let's say 3 commits ago, you forgot to add a file. I mean, it happens. How do you do that?
Yeah.
I can show you how to do that in a minute
Cool.
after we.
Yeah, so
this.
I'm going to send a pull request. I'm going to create a new pull request here. Now, right, I create a PR from the default branches. Well, no, I'm going to compare my new Fritz branch that I created, and I'm going to compare against your dev branch. Right, and now I've got, wait a sec, I don't know what these things are. Right? I'm creating a pull request that includes changes that you made locally on your site. This is the problem with Squash Merge.
Yes. Yeah. So what branch did you make your change in?
I made my change I created my own branch, but I created it off of master, not off of dev.
Oh, right. So you just need to change your base dev?
If I change that to over here,
Now you see just
now
your
I get
commit.
just that one.
So
Okay.
what happened there is you were targeting the dev branch, but because you made your changes off the master, you actually want to target the master branch
Okay.
of mine.
So I can then create that pull request, and of course every project has a utilities class file,
Yes.
and create it, and it gets sent then over to you
Yes.
with my fantastic naming here. Create utility CS. Okay, and we can share that. We can show your screen now if we just pass the cable back and forth.
Okay, sure.
And there we go. See,
Very
this is
high-tech.
like very high tech.
I thought there's
There,
things that would solve that for us.
there are things.
Like
and if
KVMs.
we had,
Do we have a KVM switch?
well, actually, we have multiple HDMI's, and that's what this does.
So here we see Fritz create utility.cs,
Yep.
and you have one change. And all right, looks good to me.
Yeah.
And
right.
then I can go ahead and merge this. So what did you want me to show though?
So right, I was hoping to show a little bit of the problem with Squash and Merge there, and right, I was actually merging against the wrong branch.
Yeah.
Is what we found out the problem was. So that was my mistake.
I'll go ahead and merge this. I disabled squashing and merging because
Right.
I didn't want to run into these problems again. Let's actually change gears here and let's amend a commit. from
Okay.
A previous commit. So let me git pull.
So instead of doing the rebase,
Yeah.
I could just amend a previous commit.
Oh well, so actually the way I often do it is through a rebase. So here let's
Okay.
so let's look at the history again. So let's say, we got this commit, we got this a message for Fritz. Fritz loves JavaScript. But I forgot to give it a namespace, right? So I want to amend that one. So what I can do is git rebase -i, and that's about 1, 2, 3 commits. So what you can do is head till the 3. So that's saying rebase the last 3 commits from the head. So
There went the horses.
and a message for Fritz.
Yeah.
Now what I'm going to do here is I'm going to pick E for edit.
Okay.
Okay. And then I'll close it. Okay, close that.
Too many hotkeys.
Yeah, save it. Now it's running the rebase, and here's where I'm in this really interesting state. I'm in this state where I'm not on any given branch. I'm on that commit in the middle of a rebase.
Oh wow.
So
Okay.
you don't want to you don't want to leave this in this way because I've had so many times where I got interrupted, came back, thought I was on my branch, but I was in the middle of the interactive rebase and started mucking around with history, right?
Okay.
But so now what I can do is I can go to that file and say namespace the hard truth, and
We're
string.
yes.
I'm just making up code now. This isn't any real language here, right?
Sure.
Okay.
Great, and I mean that's a key point that we need to make sure that folks also understand is this isn't a .NET thing, this isn't a JavaScript thing or a Ruby thing. It's its own unique. Git is its own unique thing that isn't compiling or working with your code. It's just pushing text around.
Okay. So there's a lot of instructions here, right? But what I need to do now is I made this change. I'm still in the middle of this rebase. I'm still editing this commit. So I'll say
Okay.
git add my changes, git commit -- amend, and now
Oh,
we can
look at
see
that.
that's the commit message. I'll just go ahead and save that. I don't want to change this message. And then git rebase -- continue.
Okay.
And now it completes the rebase. So let's just go back to GitHub. And we can see a message for Fritz, I've changed the commit.
Ah, okay. So let me unwind that and make sure I recap and understand what you did there. So rebase -I lets you look at all the commits and kind of merge them into one if you want, or two, or however many fewer.
Mm-hmm.
You stopped it in the middle, and the one file that you want, that one commit that you wanted to change, you changed by using the amend command with a commit.
Correct.
And let it finish putting it together so that that one that you changed still stuck around, but you changed it in history.
Right.
Okay. Now,
Let's do it again.
but I noticed the timestamp still keeps the 7 minutes ago. That amend that you did, even though it happened now, kind of disappears, right?
That's right. Basically, this is what we call rewriting history, right?
Okay.
And this is one of those things when you're from a different background, like Subversion sounds scary.
Yes.
Like, how can you rewrite the history of a Git commit,
Okay.
right? Every change should just be immutable. But Git is fine with mutability. The general practice is, when it's on your machine, before you send it up, all bets are off. Go to town, have fun.
Yeah.
But
It's your own responsibility.
Yeah, once you push it, you don't want to be amending history anymore.
Yeah.
And the reason is if someone has branched off that and you rewrite history, you just put them in a world of hurt. They're in a really bad state.
Yeah. They're in jeopardy.
I know someone mentioned the detached head state is what it's called when you're in the middle of a rebase and you're on a commit that there's no branch pointing to it.
Mm.
One thing, one of the cool things about Git, the reason why branches are so what we call cheap or fast
Mm-hmm.
is that a branch is just a pointer. It's just a pointer to a commit. It's a label.
Oh,
It's saying,
okay.
Commit, A B A D D D B. That commit is, I could create a branch pointing to that commit, and it's just a label. It's like, oh, that's it.
Yeah, it's just a stack of here's all the changes of things, and these are pointers to items in that stack.
Right. So when you create a new
Okay.
branch, it literally just creates an entry in a text file with the branch name and
Wow.
pointing to the commit, and that's
Okay.
it. All right, but I want to.
Simple when you think about it. Oh
There's
my
a couple
gosh.
other scenarios that I want to show because this often trips people up. So
Okay.
we're gonna go back here. What I want to do here is, so we're back in that state. I want to let's say echo test to test.foo, and then I'm gonna git add -a. Can't type today. Git commit, new commit, git RBC. Now let's see what happened there.
RBC.
Oh, sorry. Git rebase -- continue. I
Mm,
aliased it
okay.
to RBC. So what you see there is that's a scenario where I actually wanted to add a new commit in the middle of an existing commit. So you see new commit,
Oh wow.
a message for Fritz.
Mm-hmm. Mm-hmm.
Yes.
Thank you for the follow.
There's a lot of other cool things you can do too. Oh, whoops. I don't want to do that. So let's say you're working on code here, and I want to actually amend a message for Fritz.
Mm-hmm.
Or
Mm-hmm.
let's say I want to amend new commit, right?
Sure.
But I don't feel like doing the rebase just yet for some reason. Echo bar into Bazinga. Okay.
There you go.
There we go. I can git cm, so this is my alias again, git commit --m.
Mm-hmm.
I can type fixup, and then I can give it the name of the commit, new commit. I think this is the way to do it. Let me just. And now if I do git rebase -i add tilde 4, do that.
Okay, head ~4, is that
It
saying...
didn't work. Let me just try that. So what's supposed to happen is this is, it's supposed to match this up. I might have some git setting wrong. It's supposed to match this up and automatically put this here as a fixup. So F. So
Okay.
fixup is basically a squash. It's a squash, but you're going to use this commit message, so it won't prompt you to, merge the two. It's
okay.
just saying, yeah, just take this and put it into there.
Thank you. Space Shot in chat is recapping. Head ~4 is saying go back to the previous 4 commits from the current, where we currently are in the stack.
That's
in
right.
The version history.
Yeah, so head is always pointed to the current commit of the branch, and then ~4 is the first
Go back 4.
children. Yeah, because keep in mind that you can have merge commits, so then you have to know, well, which direction do you want to head and all that.
Oh,
yeah,
man.
so there's a whole syntax for that as well. I don't bother.
You're too good for that.
Yeah, I just try to avoid merge commits. No, I'm kidding. One other thing. Git rebase -i. So let me look at my history
Okay.
now.
And -i we've been using a lot with rebase. That puts us into that interactive
mode, right.
What if you don't do it -i?
Let me show that in a second.
Okay.
Yeah. That gives you a lot less control. That means like you're already set up. But so one last scenario. So I got what was the commit again that I wanted to new commit. Okay. So let's say I want to edit new commit. But in this case, so we're on new commit, but what I want to do is I want to remove a file.
Okay.
Actually, I want to, a more realistic scenario is I actually just want to make I want to get the previous version of this file. So actually these files were both added, so this isn't going to work. But I'll just show you, this comes up a lot, right? Like, let's say this test.foo was modified in this file, not
Okay.
added. And I want the version in the previous commit there, right?
Mm-hmm, mm-hmm.
I don't want to manually edit test.foo to the previous commit. What I can do is I can check out head ~1. So remember that I'm currently at this commit.
Right.
Head ~1 is the previous commit.
Okay.
And then I can do the path to the file, which would be test.foo. And what that's telling you is check out test.foo from the previous commit into my local workspace. Then I can just commit that and then continue the rebase. And so that's how you might, like if you made changes and you just want to reset those changes in a single file on a commit, that's how you do that.
Wow.
I didn't set it up properly, so I can't really show it.
The scenario.
Yeah, I can only show you the command. So you can pretty much fix all your mistakes. And it's there's this great blog post written by a former coworker of mine a long time ago. It's called A Thing About Git. The thing about Git is you want to get in the flow, just write code, right? And
Yeah.
you don't want to be
Let the tools fall by the wayside. Let me focus on
Right.
my business problem.
But at some point, you want to tell the story of like how you got there, right? And that the story is your Git commit history.
Okay.
And so no matter what you did wrong, you can always fix it up before you push it. And so that's the nice thing about it.
Thanks so much for the cheer, Fanny Reinders, with 250 bits. I'll make a donation to Coder Dojo for that. And I also want to thank Coding Accountant for the sub a little bit earlier. Thanks so much for that.
Okay, so great question. So Git GC, I know how it works locally, not sure how it does it on GitHub repos. So Git GC cleans up the like stray commits, right? Like if a commit, if a branch, like you remove a branch and you have these, or like if you do a rebase. So for example, what's really happening with the rebase is those commits aren't moving to another branch.
Right.
So you asked about rebase. Let's actually talk about that real quick.
Yeah.
This will lead into answering that question. So I'm going to git checkout -b a rebase branch. I'm trying to think of clever names, but I just can't do it. Okay, echo foo.cs foo into channel 9.cs. Okay. And then git cm add channel 9. And let's do echo detached head into detached. Then git cm.
So you're just creating some text files real quick so that chat room knows what's going on.
Oh yeah, I'm just creating a couple commits, right?
Yeah.
GitHub. So in fact, we can see that GitHub dot. So I'm on a branch and I created 2 commits.
Right.
But imagine, meanwhile, the master doesn't have those 2 commits. So someone else is committing on master, right? Git echo Windows XP into file.cs git cm a commit on master.
And Space Shot, that's another good question that we need to come back to in just a few minutes.
So here we are on master. We have a commit on master. And if we go back to rebase branch, we have these 2 commits, right? So what's going to happen if I merge them? We'll have, a merge commit. But maybe I don't want to. Where am I? Okay, maybe I don't want to merge branch, right? Maybe I just want to rebase these 2 commits against the most recent master commit.
Mm-hmm.
So if I do git rebase master, what's that? What is that doing? Well, what that's doing is that's replaying these 2 commits against the commits in the master branch, as if like it rewound them and then pulled in the changes from master and then said, okay, let's replay those commits.
Okay.
And if all goes well, it just works. And now, if we look at it, it's as if I had been working on master that whole time, right?
Ah.
So that's what rebase without the -i does.
Okay. It
Now,
just replays them. It doesn't give the ability to do the squashing and fixing up.
right, it just replays them. Now, here's the thing. I should have shown it earlier. The commit SHAs have changed because the parent of this commit is now this other commit, right?
Mm.
And the SHA is sort of a hash of the contents and the parent commit
Okay.
location.
And that's that it looks like a jumbled block of text that we use to identify each one of those commits.
Yeah. So I actually have a tool that only runs on Windows called cgit. It's an open source project.
Okay.
But you can actually visualize some of the stuff. It'll show you it shows you the graph of commits of every branch. And then if you do a rebase, you see the new commits, but you see that the old commits are still there. So if I had taken a note of, that old commit, I could still get to it. In fact, there's something called Git
The reflog?
reflog. Thank you. So I can actually see, these old commits where they were.
Mm.
So they stick around until you run git gc, and git gc will say, okay, any of these commits that aren't reachable.
Those hidden ones.
Yeah, those hidden ones, the ones that there's no branch that reaches that commit, then it'll clean that up.
Mm.
So the question then is, well, what does GitHub do? I'm not exactly. I think if you push, it will do it on the server, but I'm not actually sure about that. That's a really good question. I think I'd have to look at. I'd have to Google that one or email support@github.com. They're pretty responsive.
Yeah, that's an interesting question. There was another question that came up. It was about how do you make sure you remove those passwords in older commits? So it looks like you would do that GitHub rebase -i, edit, remove them, and then force push your updates back to GitHub.
But then you need a GC to run on the server.
Oh.
So here's the thing. Once you've pushed commits, so if you've already pushed them, change your password. Like you're done because
it's always out there.
Because someone's already probably monitoring. They've got it. Yeah. So if you haven't pushed yet, then yes, you modify the commit. If you're like local and you're like, oh shoot, committed password.
Yep.
yeah, you would modify it, GC it, and then push. But if it's already out there, change your password.
Absolutely.
Be safe. So GitHub has a cool feature though. If you push a commit and it has a known format for like a Azure or AWS token or key, GitHub will reject that push now.
Oh, wow,
they
that's
have
great.
a whole token scanning feature.
Okay.
I think it's out or beta. I forget.
Oh,
But-
that's very cool.
Yeah, so they've been working with like AWS and Azure for that kind of thing, and I think hopefully we'll see more of that, where you know, a little more effort to protect you from yourself, because I remember I think there was a blog post with someone who lost like a crap ton of money because
Yes, because they publish their password.
yeah
And-
they published their like token right for the AWS and you know, just these bots that are scouring GitHub looking for that sort of thing set up Bitcoin mining because that's what you do when you want to steal money, right? And so
Wow.
yeah, so as soon as it's up there, somebody's already mining you know, Bitcoin.
Yeah. Oh my goodness. A little bit ago, where was it? Simon commented and said the better answer regarding password storage or token storage is to create alternative secure storage that's outside of your Git repository. Yeah,
Well,
that makes perfect sense.
Yeah, that's hopefully what you're like. You shouldn't have been committing it in the first place because you should be using key storage, vault storage. any
Yeah,
kinds of-
some
any-
sort of key vault, a file outside of the repository. Thank you for the follow, Distorted Cohort.
Yeah, so someone mentioned Azure Key Vault. So that's, yeah, or even environment variables is preferable to committing it into thing. So for an app that you're using, I would use something like Azure Key Vault.
Yeah. Sometimes developers submit binaries, says Fuel Snable. Those ones like to remove use Git history filtering. I'm not quite sure what you mean there.
Which one are you looking at?
Fuel Snable. Fourth
Snable.
one back.
Sometimes devs submit binaries. Those ones like to remove using Git history filtering. Okay, yeah. So I think he's talking about Git filter branch, which is a very complex command to use, and I don't have it memorized. So
Okay.
I always Google it. But the idea is this: you should not be committing binaries as much as possible into Git because the way Git repositories can stay relatively small is that text files changed in a predictable manner, and you can compress those changes and yada yada. But binaries, they change. They're binaries, right? They change, and anytime any change, you're pretty much storing the entire file again, versus just the diff, right? Git doesn't do any binary diffing. So, so DLLs like NuGet and such, package files, you don't
Zip files, same way.
That's hence you want to use git ignore to ignore those. But let's say you have a repo and in the past you did commit those things.
Sure. You've got images that go with your website.
Yeah, I mean, I was responsible for some of that because in the original NuGet we promoted committing because NuGet didn't have package restore yet, quite the same way.
Yeah.
And we wanted, because the downside of not committing packages, for example, is if the package is ever pulled or anything from the source, then you can't build that version of the commit. So you want ideally a local repository for packages, but that gets into...
There's a philosophy around package management and keeping track.
Yeah, but the point is that there's a way to run something called git filter -branch, and you specify, give it a script, and it will run against a pattern, and it will find, for example, all these binary files, and then remove them from the history, and then you have to do a force push. Now,
Wow.
So again, force push. So if you do this, you need to coordinate with everyone you're collaborating with, because their history is going to get screwed up, and any branches they're working on are going to get screwed up. So they'll have to, re-pull and maybe rebase their work against the new stuff. But so you can't. So someone's like, so you can ignore zip files. You just, edit the git ignore file. So, excuse me. So I have a git ignore file here, and I think that zip is not included by default, but I would just go in here and do star.zip, and now Git will ignore all your zip files from now on. So so that you don't accidentally add them in.
Kato Kite, yes, you can troll your friends by force pushing, and they will be very upset at you. I think Legendary Moo has a good comment here. The recommendation with binaries is to publish those to some form of package manager, such as NuGet or private Azure DevOps package manager. I think, right, it's a good idea to put a copy in those locations because you don't know when they might disappear from NPM or NuGet. If you're depending on one of those, to have that copy that you're depending on, you've pushed to production somewhere, to have that available all the time, I think is a good idea. Putting it into Git and GitHub is not the right place. But NuGet does try to be immutable. You can't remove things from NuGet by just going there and clicking delete. It's not possible.
Okay,
NPM, you can.
So someone mentioned I only use few branches, and when I'm done, I check out master and I merge, then push. Is it fundamentally wrong not to not rebase, do merge commits, whatever that is? Oh, okay. So there's no fundamentally wrong or right answer here. It really is a matter of preference, especially if it's your solo project. You can do whatever you want. There's a real benefit to doing merge commits, which is you can see very visually and easily, especially if you're the only one working, like each line of work, right?
Mm-hmm.
Whereas if you rebase and push, then it's a single historic line, and you can't see like where each feature group is. But you can go to pull requests and see it. So that you still have that, but from your Git history alone, you don't see it. But you will. This is like tabs versus spaces. This is like semicolons on its own line or new line. People will get into major wars about this. I really don't have the time anymore to worry about that. So I click the green merge button, and if I'm working with someone else and they tell me to squash merge, then I'll click that button instead. But I just I don't bother with it. When I'm working locally on my branch, I do tend to rebase, but I still, when I push, I'll just merge, click the green merge button.
And just let it go.
And let it go, yeah.
Let's see. Git LFS for big binary files. So Git LFS, that's for large files.
Yes, that's right. This feels like kind of like Ann Landers for Git. I should start a Git advice column.
Absolutely, right? For developers.
Tell me your Git woes, and we'll talk about them. All right. So LFS is large file system. So this is a great point. We mentioned earlier, don't commit binaries to Git. However, let's say you're working on a game, right? And game, you're going to have these large images,
sure,
and
models,
scenes and models and all that. And ideally they would all be vector, but a lot of times they're not, or they're in some obscure format. Or, like maybe you really want your local copy or package files because you don't want them, you want to make sure that they're always available. Now,
maybe the network goes down between you and NPM or NuGet, right? You want to be able to do everything locally.
Right. Then you can use something, you can use Git LFS. So Git LFS is an extension of Git, and what it does is in place of the binary file, it puts a little text file and then has the address of the binary file. And the binary file is actually stored in some other location, typically like they do Amazon AWS S3 or Microsoft Azure Blob Storage, or there's local inside your network artifact repositories like Artifactory and I don't know. There's so many now.
Yes, there are.
But that is a good way to use Git LFS, and then Git LFS also supports, or you just that's great for like game development. The other option, which is the Git virtual file system.
Okay.
So are you familiar with this?
No.
Okay, so
is this the thing that I've been hearing the Windows folks talk about?
Yeah. So
okay.
if you've been following Windows development, and by that I mean the development of Windows itself, they had this big one engineering initiative, and they switched everything from their internal system to Git. And you're like, how the heck are you going to put the potential terabytes of source code files for Windows in Git in a Git repository? And the way they do is they wrote their own virtual file system, and this means that when you check out a repository, it doesn't actually download all those files to your local machine. It just it looks like it does, but the files are still hosted on some server until you try to touch the file. Then it just in
Real
time
quick.
downloads the file to your
Yeah.
local machine. And so that's that helps because when a Git repository gets to be a certain size, it can get really slow to do certain operations. And so it's one of the reasons why we say don't put binaries in, because you don't want your repository to get extremely large, like a terabyte. But with Git virtual file system, you can actually make working on those manageable. And in fact, it's a similar approach to Facebook does a monorepo for all their code, and they use Mercurial, which is also a distributed version control system. But they built, from what I hear, they built their own virtual file system type approach for that.
Now, I'll let you finish, but I want to you use the term monorepo. I want to make sure we come back and talk about that.
Actually, I was done. So,
okay.
So there's, we talked about these religious battles or these style battles.
Philosophy. Developers as philosophers.
Right. So we talked about, whether to rebase, merge, squash.
Yes.
The other one is do you have a single repo or multiple repos for your projects, right?
Sure.
Especially for larger projects.
Sure. I've got a base library that has some shared objects in it. I've got another library over here that has stuff that happens on an application server, and I've got another library that has the web application, and another thing over here, another project that's the mobile application. Or they
right. You have the mobile app, your client app, your web app, your microservices. Are they all in their individual repos, or are they in a single repo?
Right.
And the correct answer is it depends.
No.
Well, so it was interesting because so one of the projects that I was at GitHub, at the end I was a director, and so I had several projects that reported up to me, and one of them was Atom, which is a text editor. Mm-hmm. And so Atom started off with, it's designed at its core to be extremely extensible, right? So you had the core Atom shell, and then almost every feature was an Atom extension.
Okay.
So you could take it apart, put it back together any way you wanted. And every extension had its own repo. And it turned out that it was a bit of a maintenance nightmare, because anytime you made change to this repo, you had to track multiple repositories and dependencies and all that. So what they ended up doing is they didn't quite go monorepo, but they basically took the blessed list of core extensions, and they moved them all into the main Atom repo, and they found that the development progress just took off like a spike. So
really?
Yeah,
okay.
It's just so much easier to manage the dependencies and interdependencies that way. So that's the benefit of the monorepo. The downside of the monorepo is that you have this giant one repo, and sometimes I want to just make this change here, and I want to be able to do it in isolation and not affect things over there, and I don't have to check out the entire code. If I'm working on the mobile app, I don't want the entire web server code
No.
either. So I don't believe there's a right answer. It's just a matter of style. I've certainly used to be more on the non-mono repo, but lately, seeing some of the challenges of working with many repos, I definitely get the appeal of mono repos.
Yeah. Legendary Moo says we need to add Phil saying it depends as a soundbite for the bot. That's not a bad idea.
Favorite answer to every question. It depends.
It depends.
But it really does.
Yeah. Git submodules, that's a whole nother ball of wax, isn't it?
Yeah, Git submodules. So what a Git submodule is you can, instead of using a package, referencing a package dependency, you can basically clone another repository into your repository via a submodule, Git submodule add command. And what that does is that it copies it over, but from the Git side, it's just a pointer to that other repo. So that way, you're not actually copying that code into your repo. It's just adding a line that says, this commit in this other repo should go here when the user clones it locally. And then, you can make changes to that, but then, you have to remember to push those changes up, and it's very easy to get out of state with that.
And manage the two repositories now that you're working against. Oh my goodness.
Right, and then there's the another related thing, there's Git subtree, which not a lot of folks know about, which is similar to Git submodules, but in that case, it really does copy the code from a remote repo into your repo, which is nice so that you never run into a situation where like you pull latest and your submodule is pointing to something that isn't available because maybe they squashed.
Oh, man.
Like back to squashing, right?
Yeah.
So what Git subtree does is it copies it, but it keeps the pointer to the repo so that you can easily pull in new changes from that other repo.
Okay.
But you always have a copy of the code in your repo that's committed with your code.
That feels safer.
It feels a little safer. It just takes up more space, right? So
Yeah.
it's like the other side of the it depends is it's a series of trade-offs. Everything's a series of trade-offs, right?
Absolutely.
So in that case, you're trading off convenience for disk space,
And disk space
or
is cheap.
repo space.
Sure.
So when repos get too big, it does become a problem. But if this repo you're pulling in isn't that big, most repos are not going to hit that size. So.
Absolutely. I think we're just about at time. This has been good. My gosh, a couple folks here were saying that.
Do you see this joke? I read a joke. God gave us Git. The devil got jealous and gave us Git submodules.
Whoa.
So
come
Git
on
submodules
now.
is like SVN externals. It's pretty close.
Yeah. All right. This was great. I saw a couple comments there earlier. Folks really liked seeing all the different things that we could do here. There's, yes. Thank you so much, Phil. This was thank you very much for joining us.
It's been my
I know it's
pleasure.
been a while. We've been trying to get this to happen, but finally got to have the discussion about all the cool things you can do with GitHub and Git back and forth. Really, really neat stuff. I want to set up for a raid. You're a Twitch guy. You know what's going on here. I think we need to set up a raid so that we can go and send all of our friends that are watching right now.
I have no idea what a raid is.
You do too know what a raid is. We're going to send everybody to go see our friend, the Michael Jolly. He's another one of the live coders. 66 of us on the team here that are all writing code, teaching live on Twitch. And the Michael Jolly is over there right now on his channel, writing some code. He's doing some refactoring, working in Visual Studio Code. We're going to go say hi to him. So, folks in the chat room, here's what I want you to do. If you're a subscriber, grab that first line of code. If you're not, that's okay. Grab that second line from the chat bot, and we're going to announce our presence when we get over there and say hi to our friend, the Michael Jolly. All right, let me set up the raid command.
Oh, and check out GitHub for Dummies if you're interested in. So this is a book that I wrote with a colleague, Sarah Guthels, and we talk a lot about GitHub as well as some basics of Git. But it's a nice tour of the feature set of GitHub, which a lot of times people only stick with one or two, but you kind of get the whole breadth. So
Very cool. Well, thanks so much, and friends, go say hi to the Michael Jolly when you get over there, and I'll see you back here tomorrow morning, regular time, 10 a.m. Eastern, 7 a.m. Pacific, 1400 UTC. And this video, like all my other videos, will be available on the YouTube channel a little bit later this week. Take care, everybody.
bye.
And they're